Okay, this is PowerPoint 1.1.3 Scientific and Engineering Notation. This is a very important and key skill. You probably have some knowledge of it from previous Project Lead the Way classes. Okay, this presentation will demonstrate how to express numbers in scientific notation. Also, how to express numbers in engineering notation and expressing numbers in SI prefix notation. Alright, scientific notation is a way of writing very large and very small numbers in a compact form. And numbers written in scientific notation is written in the form of A times 10B. A is a number, it's greater than 1 and less than 10. And B is an integer. So there you see some examples. Okay, here's your examples down here. 3.24 times 10 to the 5th power. Also could be, it's an integer, so it could be negative numbers as well in the power. Okay. Writing a number in scientific notation. Shift the decimal point so there is one digit, and the digit cannot be 0, before the decimal point. Okay, so there needs to be one digit before the decimal point. Multiply by a power of 10 equal to the number of decimal places your decimal point has been moved. Alright, and we'll look at that here in a little bit. Finally, the power of 10 is positive and the decimal point is moved to the left, and negative if the decimal point is moved to the right. So let me repeat that. The power of 10 is positive if the decimal point has moved to the left. Alright, if it's been moved to the right, it's going to be negative. So here is an example. Express 5,630 in scientific notation. Okay, so your decimal point, even though it's not there, it is there. Okay, so it needs to move over 1, 2, 3. So it gets written as 5.63. You don't really need the 0, you can drop it. So we moved it 1, 2, 3 times. So it's the third power. 5.63 times 10 to the third. Alright, now this one we're going to move it to the right. And remember, when you move something to the right, it's going to be negative. So let me write the number out. Okay, 1, 2, 3, 4. 6.28. And we moved it over 4 times to the right, so you're going to get negative 4 times 10 to the negative 4. There you go. Alright, so engineering notation is very similar to scientific notation, but the powers of 10 are the powers of 10 are always multiples of 3. That is super important. A number written in engineering notation is written in a form just like A times 10 to the B. A is a number greater than 0 but less than 999. Very important. And the power is an integer and it has to be a multiple of 3. So here's some examples that they include down here. And you can see 3, minus 6, 9, minus 12. Those are all powers or multiples of 3. Multiples of 3. That is one of the most important things to understand in engineering notation. So, writing the number in engineering notation. Shift the decimal point in groups of 3 until the number before the decimal point is between 0 and 999. Multiply by a power of 10 that is equal to the number of places the decimal point has been moved. Again, if the power of 10 is positive, the decimal point is moved to the left. If it's negative, it's been moved to the right. So here's an example. Alright, express that big number there in engineering notation. Now, it's going to be very difficult to do. Let's see if I can, though. Okay, so 1, 2, 3, 5, 6, 7, 8. Now I don't want to stop at 8 because it needs to be in a multiple of 3. So I need to go one more. 9. So 16.346, 10, and it's to the ninth, and it's left, so it's a positive 9. So there we go. All right. My number needs to fall between 0 and 999, and of course that number does. All right. So let's do example 2 now. I'm going to move this one to the right, so I know it's going to be a negative number. It's going to move 1, 2, 3. Oop, I lost my count. 5, 6. All right. So 348.6 times 10, and I moved it to the right 6 places, so it's going to be negative 6. There you have it. All right. So SI prefixes, these are a short way of writing engineering notation for SI numbers. So SI stands for International System of Units. It's a French word, and it's a modern form of metric system. It is the world's most widely used system of units for science and engineering. So that's why we're going to use it. And we basically stick with SI prefixes. All right. So here's a chart, and you're going to see this chart in our classroom, but it's commonly used SI prefixes, and you can see the value is in engineering notation, meaning multiples of 3. Okay? That line right there, let's make that a little thicker. That line right there is the cutoff between a positive integer and a negative integer for your power. Okay, so here is your value. All right, this is the prefix that you will use, that you will say or you would write down, but here's the symbol. Okay, there's the symbol. It's important to memorize all this, put it on flashcards if you need to, but you got to know it. All right, so let's take a look at an example. All right. So they want us to express the number 27500 ohms using standard SI notation. Remember, that's this symbol right there is omega, and it talks about resistance. And resistance, by the way, is measured in ohms. All right, so I'm going to move this guy to the left. 1, 2, and I can't stop at 2, so I'm going to go to 3. 27.5 times 10, and I moved it 1, 2, 3 to the third. All right, that is it in engineering notation. In SI notation, it's 27.5. And since I moved it to the left 3 times, all right, I may have to look back at the chart, but I know that's kilo ohms. All right, let's take a look at this next guy. All right. Okay. He's going to move to the right, which it's going to tell me it's going to be a negative number. 1, 2, 3. Nope. 4, 5, 6. Why wasn't it going to be 3? Well, if you remember, it has to fall. All right. It's got to be a whole number. Okay, it's got to have a whole number involved with it. So that is going to be incorrect. So it's going to be 5, 6, 8. All right. I moved it 6 places to the right, so I know it's going to be negative 6. All right. But negative 6 is expressed in micro, which is like that little U symbol. And we're talking about volts. Okay. Here are some common electronic symbol in units. All right. We deal a lot with this. Your top 3 here. Okay. However, down here, we will deal a lot with frequency, especially when we start dealing with counters and such. Alright? Capacitance, a lot with analog stuff. Inductance, we don't get into a whole lot, and then there's a little bit about power. Alright, but these three up here plus frequency are ones that we deal with a whole lot in here. We need to memorize those, including the symbol and the unit. And that is our presentation.